Hey everyone, welcome back to my channel Physics with Sebbi. Let's have a look at the spectacular question taken from optics appeared in JEE Advanced 2025, but with two answers. Why we are getting two answers means there are two possibilities. A solid glass sphere of refractive index mu is equal to root 3 and radius r contains a spherical air cavity of radius r by 2 as shown in the figure. A very thin glass layer is present at the end point O so that the air cavity of refractive index mu is equal to 1 remains inside the glass sphere. An unpolarized unidirectional monochromatic light sources emits a light ray from a point inside the glass sphere towards the periphery of the glass sphere. If the light is reflected from the point O and is fully polarized, the angle of incident at the inner surface of the glass sphere is theta. The value of sin theta is Before going to check out my solution in detailed way, explore your wonderful thoughts to crack at it. Now you watch the solution, which has two fairly tricky paths. In this problem, our target is to figure it out sin theta value. I came here to explore the solution with simple animation for better understanding. This is the glass sphere of radius r. Inside the glass sphere there is a air cavity of radius r by 2. This is the center of bigger sphere, means glass sphere. This is the center of air cavity, and O is the point at the bottom at which the polarization takes place. S is the monochromatic unidirectional source. It emits the light which is incident at the periphery of the glass sphere and reflected like this. This process continues. Here at this boundary the refraction takes place and incident at point O and gets reflected, and some light gets polarized through this small thickness. Now you draw the normal at the point O, and at this point also one normal is drawn. Here is another, here is also. Finally at this incident point also we have to draw one normal. Then if you see that by using Brewster's law we have to find out the polarizing angle at the point O. Here this is air and this is the medium of refractive index root 3. There is a polarization at the point O. By using Brewster's law we can find out theta p, polarizing angle. Tan theta p is equal to root 3. Root 3 is nothing but the refractive index of the glass sphere. From here we can find out theta p is equal to 60 degrees. These two are radial lines. Here the angle is 60 degrees. Here is also 60. By using Snell's law you can write root 3 of glass medium, means the refractive index of the glass medium root 3 into sin angle sin r is equal to the refractive index of air medium 1, and here the angle is 60 degrees, therefore you can write sin 60. From here we can get r is equal to 30 degrees, means this angle is 30. Now if you observe this line, this is the horizontal line, just you extend this. Now we have to find out this angle theta. We have to find out this angle theta. This angle theta which is equal to this angle. Why means the angle of incidence is equal to angle of reflection, and these two are radial lines. Therefore here the angle, here the angles are equal, and these two are radial lines. Here the angle, here the angle is same, and angle of incidence is equal to angle of reflection. Therefore this theta is equal to this theta. Now if you extend this horizontal line further, it intersects this perpendicular line. Now you are getting a right angle triangle ABC. Here to here, this is the radius of glass sphere, and here to here the radius of air cavity, and this will be the bisector of this triangle, isn't it? Therefore, this total length is r by 2, this length is r by 4. Therefore, this point to this point, the length is 3r by 4. Therefore, sin theta is equal to, for this theta, sin theta is equal to opposite side 3r by 4 by hypotenuse r. Therefore, sin theta is equal to 3 by 4 you are getting. From there, sin theta is equal to 0.75. This is one answer. There is another possibility. See here. This is a glass sphere and this one is air cavity. S is the source. From this, a light is emitted and incident on the periphery along the normal. Here, along this normal, it is incident. Then what happens? It's reflect back up to the center of the glass sphere, and this is the boundary between the glass and the air. Therefore, it gets refracted and incident at this point. Now here also it gets reflected and incident at this point, and gets reflected, incident at this point, like this. It is given in the problem. Draw the normals at all incident points. Then what happens? At the point O, tan theta p is equal to root 3. From here, theta p is equal to 60 degrees. Means you are getting here 60. If it is 60, here is also 60, because these two are radial lines. If the angle is theta, here is also the same, and angle of incidence is equal to angle of reflection. Therefore, if this angle is theta, here this angle is also theta, and here is also theta 60, here is also 60, here is also 60. Now at this boundary the refraction takes place. Therefore, if it is 60, this will be 30 degrees, like this. By using the Snell's law we can find out. Okay, means if theta is equal to 0 degrees, then there is a possibility like this, and you will get the polarizing angle 60 degrees at the point O. Means sin 0 value is 0. The second answer is 0. First answer is 0.75 and the second answer is 0. Are you enjoyed this video? Subscribe for future updates. Please like and share the video. Have a nice day.